All right, so it's time. The Dart 250 that I've been showing in the last couple of videos. Actually broke a piece of foam off here I need to fix, so just kind of ignore that. But we've been flying it recently with iNav 3.0.1, if I remember right. It's definitely 3 point something. It's iNav 3 that's on here right now. We have the Maytech F411 WSE, which you probably can't really see in there and into the dark fuselage too good. But pretty basic little iNav setup. We got 5.8 gigahertz video transmitter back here. We got crossfire. You can see my receiver here. In the last video, I mentioned that I needed to move it further away from the GPS. That's my GPS receiver right there. See this little hole right here in the top of the fuselage? That's where this antenna used to poke through. And I just moved it out here on the wing. You can see my receiver is just kind of dangling right in there right now. Kind of right there, you can see it. But anyway, so it's time. We're going to put iNav 5 on it. So in this particular video, I kind of planning on just doing the basic install and configuration and settings and things like that. And then we will get on and fly it as soon as we can, as soon as the weather allows, because it is pretty windy today. And we got some more thunderstorms and stuff like that moving in. So we're going to get on with it and get iNav set up and installed and configured and ready to maiden. And in the next video following this one, we'll probably do the maiden flight or remaiden with iNav 5 and do the auto tuning and stuff like that. So let's get on with it now. So alright, so first things first, we're getting started here. We have the Dart sitting here on the desk. I have my radio here handy just for when I need it later. We have iNav up on screen that you can see here. Now this is the configurator for 3.0.1. Which is the version that's on here right now. I want to use that version so that I can connect to the airplane, to the flight controller, and take a quick look at some of the specs, as well as make a backup of my current configuration. So to start with, we'll go ahead and plug in the USB cable. When we do that, you'll notice right up here we have COM3 that shows up. So we want to connect to it. And you see we're talking to the flight controller now. If we move airplane, you see the model on the screen there reacts accordingly. So the first thing we want to do, we just kind of want to take a quick look down here at some of these settings down the list here. And calibration is not important. Mixer, you're going to be setting this stuff up in iNav 5 anyway. Outputs, ports is kind of important. You want to take a quick look at that. Just kind of take note of what's where. Chances are you built your airplane, so you know what ports are where your receiver's connected, or your GPS, stuff like that. But just, if you need to, you just want to take a quick note of what's here. And this particular little wing, like I said, I have a 411 WSE in here, so I'm kind of limited on the ports. I have my GPS connected on UART1. I have my receiver right here on UART2. I'll have soft serial enabled, and I'm using soft serial 1, which is the ST1 pad. I'm using that for TBS Smart Audio. And the receiver in here is an AKK Tech X2 Ultimate, which works on the TBS Smart Audio protocol. So we're using that to control the band, channel, and output power. Configuration, I don't think there's anything real important that you need to take note of here. All your basic stuff, you're going to be setting this stuff up again anyway, but it doesn't really hurt to take a quick refresher. PID tuning is not important. We're not going to use any of this anyway in 5. We're going to be retuning in 5. But that's what was in here before. Advanced tuning, the same thing. We're not really going to be reusing any of this stuff. These are a little bit slow to load sometimes. They're waiting for data. But if I remember right, in here you have like your auto launch settings, which I'm still not using auto launch in this little plane, so I've never really changed any of this stuff. Same with your battery estimation settings. Now your navigation settings, your cruise throttle, and max throttle, stuff like that. You might want to just take a quick note of it. And again, you should know your airplane, and you probably already set these up. If they're not on defaults, it's because you've changed them, so you should probably remember what they are and know your airplane, and you'll be able to set it up again. At least you should. Again, here for your RTH settings, some of these are kind of important. You want to take note of those. Like I particularly like to run at least with linear descent mode for my RTH altitude. I climb before RTH. I like to run that on fixed wing spiral, which means it's going to kind of spiral around its position where it enables RTH. It'll climb to your RTH altitude and then make its way home. It's kind of just in case you happen to drop down behind some trees or something and lose your link. Trigger RTH. It's not just going to swing around back into those trees which blocked your signal in the first place. It'll climb before it points itself home. So I kind of like that feature. Personally, I leave land after RTH to never. You can set it to always or failsafe only. So if you manually trigger a return to home and you have it set on always, when it gets home it will land. Or if you set it on failsafe only, obviously it's going to land when it gets back to the home position in an actual real failsafe condition, not just flying in RTH flight mode. But I prefer never. I don't want an airplane to land itself. It kind of gives me a chance to maybe fix any problems that I might be able to fix on the ground. And if not, it'll just loiter overhead until the battery runs out and it'll land anyway. So I prefer to run that on never. Then you have your navigation settings, your waypoint settings, stuff like that. We're kind of looking past what we really need to focus on here. So let's go ahead and just say that if you have anything set up in these modes, like this is how I have it set up to control my VTX power level. Just custom stuff like that. You just want to take note of that stuff and you can restore it after we upgrade. Receiver, your receiver protocol stuff. That's pretty simple stuff. Flight modes, you can scroll through and take note of those, but again, that's all personal preference that you've already set up, so you should be able to do that again. So OSD is probably not important, and it's another tab that's slow to load. Because there are a few changes in iNav 5 in the OSD, at least coming from 3.0. I know there's some changes in 5 from any other version anyway, a few good improvements there. But once again, we're going to be doing a backup, and we'll pull most of this OSD layout from your backup, and then you can kind of make changes as necessary. So let's just jump right back down to the main reason we're connecting to the board right now. We want to get a dump. Just type dump in the CLI, hit enter, let it finish populating. When you see this batch in, you know it's done. So then you just want to click copy to clipboard. You'll go make a new text file on your computer and you paste it into it. I've already done that beforehand. We can reload that. You see, I've titled mine 3.0.1 final before update to 5, and it's just a text file. Open it with Notepad, pasted this dump in here, and this is basically a backup of all the settings in your flight controller. And like I said, we can pull some of this out. It's not recommended to just restore this dump into 5 because some settings have changed, especially with your tuning and stuff like that. And some features were taken away, some were added, and some of these settings will carry over, some won't. It's best just to start with a fresh install and manually set it up. But we will refer to this, and like I said, I will be pulling the OSD layout from here, just kind of as a shortcut. We'll just minimize that to save it for later. So when we're done with that, we can go ahead and exit, which is going to reboot flight controller. And it reconnects to it automatically, so we can just go ahead and disconnect and close this configurator for 3.0.1. We'll close that. Now I'm going to go and open the configurator for 5.0.0, which is here. Now you see we're in configurator 5.0.0 version, and once again we want to connect to COM3, but when we do, it's going to jump straight to the CLI because it's not supported. And you can type version, and that will show you that we're running 3.0.1. We already knew that. And you just want to take note of this iNav/Maytech F411 SE, which is your target, the board name in iNav. You just want to take note of that. You should probably already know that, but if you're not sure what target to go for, that's where you get that. Just type version, it'll show you the version of the firmware and the current target, which again is Maytech F411 SE. So we can go ahead and exit, and it's going to reboot the flight controller. Actually, we probably could have just disconnected the first time. Click disconnect instead of exit. So now what we want to do, actually we did need to reconnect, so that we can type DFU into the CLI. We hit enter, and you'll notice this COM3 is going to change to DFU right here. So it basically boots the board in bootloader mode without you having to hold the button to do it. Now, when you come over to your firmware flasher, normally when you flash the firmware, it will reboot the flight controller into DFU mode for you. But for some reason, it's kind of hit or miss on this specific computer that I'm using right now. If I use my desktop computer in the house or my laptop, they usually will reboot the flight controller every time, but the USB controller in this particular computer that I'm using right now is kind of sketchy and hit or miss sometimes. It doesn't always reboot automatically, so I just like to type DFU and trigger that reboot into bootloader mode. So we want to search for Maytag just to kind of shorten the list of board names. See if we don't narrow it down, it'll just show you every iNav target that's available, which is kind of a long list. So we'll just type Maytag just to shorten it a little bit. Just look at the Maytag boards. And once again, we're looking for the F411SE, which is this target right here, which is the default, the standard target for the F411 Wing SE board. And now you want to choose a version. We want to choose 5.0 stable. You do not want to turn this on. You want to leave your reboot sequence on. You want to turn on your full chip erase. I usually just leave the baud rate on auto. And the show unstable releases option is to let's see. It's not narrowing it down for us. There we go. We'll pick the same board, and you see that when you can see your release candidates, like before it was stable, you can see RC1, RC2, RC3, or the stable. That's what this option right here does. But that's not important because we're just going to run the stable release. So we're going to pick 5.0. Once again, we'll leave these set like this, and we'll load the firmware online, and it will go out and fetch the firmware from GitHub. And you can see you have your release notes for 5.0 and a list of all your changes if you want to read them. And we're going to go ahead and flash the firmware. You'll notice it starts erasing the board, and then it's going to write the firmware. And I don't remember if it does a verify sequence or not, but we'll watch it and see. I'm not really going to speed any of this up. We're doing it all in real time. So pretty much when this finishes, as you can see it's flashing right now, which takes a minute. But when this finishes, we're going to have a clean flash of iNav 5. Programming successful. So I guess it doesn't do a verify unless it's included in that flashing progress bar. So we can go back to, or we don't have to go back to the welcome page, but we can just click connect, and it should connect to the board. And the first thing it's going to do is ask you what kind of airframe you're putting the flight controller in. And this one being a Dart 250 is going to be an airplane without a tail. So we'll click that, and it'll load some defaults for that type of airframe. And then it reboots. And it reconnects for you. Now you see we have a working flight controller once again. It's in the airplane. Move the airplane, everything works as expected, which is a good sign. And you see up here now it's showing flight controller firmware is 5.0.0. So this is how it comes when you flash firmware. This could be either an old flight controller like this one that we wiped, erased, and flashed new firmware to, or straight out of the box. You can flash a new firmware to it, and this is where you'll end up. This is where you start. So the first thing I like to do, it's not always necessary, but it's just good practice in my opinion. Just jump into the CLI, defaults, hit enter, and it loads the board defaults and reboots it. And if I remember right, it's going to trigger that thing. It's going to ask us what airframe it's in again. Yeah. It takes the defaults out of the firmware that's flashed into flight controller and loads those just in case there was any old, stray settings or data or whatever left behind from the flash, which it shouldn't be with a full chip erase, but it doesn't hurt to just go ahead and reload the firmware defaults just to make sure. So we'll go ahead and click that again, airplane without a tail. We'll wait for it to load those and reboot and reconnect. Alright, so we're back to where we were before, but we went through and reloaded the defaults just to make sure everything is good to go and as expected. So the first thing we want to do, we'll go down to Calibration tab. Now, you could possibly load the calibration data from your dump, from your previous version of firmware, if you have one. I do have it, but it's so quick and simple to calibrate the flight controller. It's easier just to recalibrate. I think it is anyway. Maybe some situations it might be difficult for you if you have it in a particularly large model or something like that. I have reloaded the calibration data for the gyros and accelerometers in earlier versions of iNav, doing updates and upgrades from one version to another. I haven't done it with 5.0, but I've done it with earlier versions from like 2 point whatever up to 3, and I know it worked there. But for this particular video, we're just going to go ahead and recalibrate the accelerometer. So to do so, obviously, you want a good flat surface. It's pretty basic stuff. Now, if you are building a new model, I recommend you do this with the flight controller outside of the model before you mount it. It's just a lot easier to calibrate the flight controller on your desk before you physically mount it into a model. But especially with a low model like this, it's not hard to do it, even sitting here at my desk. So we're going to go ahead and click start. We'll click OK. So now the first thing you want to do at this point, you want to just go, it's not really important to do them in the specific order here, but I like to do it that way anyway, just to keep track of what I'm doing. So the first step, I'm just going to hold the model flat on my desk, and it's not super important that the model be exactly flat. It's way more important that the model be, dead solid, steel, hold it against a firm surface where it's not moving. It just needs to be steel without moving at all. So we click calibrate, and that'll get step 1, which is upright. Now to do the upside down mode, I usually hold it on the bottom of my keyboard tray. So bear with me, I'm kind of moving around over here. So I'm just holding it against the bottom of my keyboard tray, which is the easiest flat surface I have that I can hold it to. We'll calibrate. Alright, now we need to hold it with the nose pointing to one side over here so that we have it with the right wingtip down, like this little indicator right here. So we have that now. We're just holding it in front of the desk. We'll click calibrate. Alright, now we want to do one with the nose up. And once again, I like to just hold it against the front of my desk over here, so just bear with me. Alright, now we'll do it with the left wingtip down. Calibrate. And now we hold it with the nose pointing down to the ground. And click calibrate for the last time. Alright, so that loaded all the positions that it wanted. Let me get my model sitting back over here on the desk so that we can see it in the camera if we should need to further in the video. Alright, so accelerometer calibration is finished. Check that the values have been saved. So we click OK, we have these values saved here, they're good. We want to save and reboot just to make sure it stores those and they don't get changed. Alright, so we finished that calibration. Now our mixer. because we told it that this was an airplane without a tail, it defaults to the flying wing mixer, which is exactly what we need for this particular model. And one change I like in 5.0 is that they've actually color-coded these outputs down here for your servos. And the servo numbers actually match the outputs on the board in most cases. I don't know if that's true for every flight controller supported in iNav, but I know it's usually the case, especially with the more popular boards like Maytech stuff. You see we have a motor connected to S1, which is where my ESC signal wire is, and then we have the elevons connected to S3 and S4, which are color-coded to which servo, which surface on the wing goes to which servo output. Now I always leave all this on default down here. This works fine for me, 50% pitch and 50% roll. So there's nothing to change here, at least in my case. And now my outputs. We want to enable motor and servo output. Now at this point, you probably want to remove your propeller just to be safe. There's no reason for the, well, it's definitely not going to start right now because I don't have a motor attached. I'm just running the flight controller off USB power from the computer. But it's a good point, just safe practice, just to remove the propeller now so that you don't forget. Do as I say and not as I do, because I'm not going to remove my propeller. I've done this enough times, I know how not to hurt myself with it. But if you leave your propeller on and you cut yourself, that's on you. It's a risk I'm willing to take. But you want to go ahead and enable your motor and servo outputs. And the ESC protocol, I don't even know what this ESC in this little wing supports. It's just the stock one that came in the PNP Dart 250. So I'm just going to leave it on standard, which is fine. You could run like D-Shot or something like that and get telemetry and stuff like that, which is something I've never used personally. So I've always ran my speed controllers on the standard protocol, so that's just what I'm going to do here. How I had it set up before, it's already calibrated, everything works fine. It's something I'm not going to worry about for now. Servo refresh rate, again, I usually just run mine on 50 Hertz. If you have digital servos, you can run them on a higher refresh rate, but I do have digital servos in this one, but I just tend to leave my servos on 50 Hertz. You do want to enable your stop motors on low throttle so that your motor does shut off when you put your power all the way back. With this being an airplane, you want to stop the motor when you land, especially one without a landing gear like this that lands on its belly on the ground when the prop hits the ground. The idle power percent is not in effect, I think, if you have this enabled, but I've never messed with this, never had a problem with it. And this other stuff too, I'm not even sure what that's for. I think the motor poles, which is the number of magnets in the motor, is so that the SC can work its RPM stuff for telemetry, if I remember right. And then reversible motors, I've never used a reversible motor on an airplane, so I've never worried about that. And everything here looks good for now. We will come back and check servo reversing once we power everything up. Later we'll double check that. We may have to come back and reverse one of these servos. If I remember right, for this particular model, I do need to reverse one. But we'll double check that later. Ports. Now here's where you want to set up stuff like we had it before. I know I have my GPS on UART1. It comes with MSP enabled on UART1 by default. But there's also a note right here. Do not enable MSP on the first serial port unless you know what you are doing. You may have to reflash and erase your configuration if you do. But it comes on by default. And as far as I know, you should be able to run GPS with MSP on the same UART. Basically, the reason you want to leave MSP on a UART, the only reason I can think that you would want to, is so that if you damage your USB port, MSP is basically the protocol that you use to communicate from the iNav configurator or pretty much any software with the flight controller like we're doing right now. And you have to have that on USB. Don't ever turn this off on USB or you're going to break your USB port. Not physically break it, but you're going to make it stop working. And to fix it, you'll have to connect with a little USB to serial adapter on one of your actual UARTs. Serial ports on the board, you can still connect to it that way, but only if you had MSP on one of your UARTs. And that's the reason you want this on. Should you ever need to connect to the board and you can't use the USB port, you can use a a UART, a serial port, that has MSP enabled. But in my case, I'm going to switch it off. It's how I had it before. I guess if I ever damage the USB port and can't use it, I'll have to just get a new flight controller. I don't know. Mark, Powell, Darren, if one of you guys are listening, you want to key in the comments, want to chime in and explain that to me. Is it okay to leave this on? What's this note about? And can I run GPS and MSP on the same port? I would really appreciate that, and if you do, I'll pin your comment. So if you're watching a video and you have the same question, maybe check the top comment. But for now, I'm going to leave it off, as that's how I had it before, and I know it works. I do have my receiver connected to UART2, which is by default for this board, so I'm going to leave that. Now, like I said, I have soft serial enabled, and I'm using the ST1 pad for TBS Smart Audio to control my video transmitter. So we've done that, and we need to save and reboot. Alright, so our next step, configuration. This is where you have a lot more settings in here. Now your accelerometer and barometer, these should be populated by default. They should be auto-detected or set depending on your firmware and your board or whatever. I've never had to change these, but I guess if something isn't working as expected, you can double check these. But these always work for me on defaults. Board sensor and alignment is correct, and again we can go back to the setup page and we can watch that. Now if you watch, you see the actual model on the bench. If I raise the nose, the model on the screen matches that, and if I roll it this way, it works. It looks backwards because the airplane's facing us instead of away, but everything works as expected. So this board alignment is correct. Other features, we want to stop motors on low throttle, enable CPU-based serial ports. GPS, we want to enable it, so we do have it set on the port, and you want to remember to also enable it here. I believe they've also added that in the GPS page, we'll get to later. We want to enable telemetry output, because we are using telemetry. Back to my radio. Don't need reversible motors, I'm not using analog RSSI, I don't have LEDs, I don't have an OLED screen. Don't have black box flight data recorder. Enable motor and servo output. I thought we already did that. Or maybe we didn't save it on that page. We can actually look at that on outputs. We didn't save and reboot on that page. So now when we get back to the configuration page, that switch should be enabled. And it is now. Okay, so CPU-based SPI, we don't need that. We do want the OSD. We want to permanently enable air mode. Like I said, I'm not using fixed wing launch mode yet. I will set that up later, but for now we're going to leave it disabled. Profile selection with stick command. I turn that off because I usually never set up any other profiles or anything. I never need that, so I switch it off so I don't inadvertently load a profile that's not set up. Throttle voltage compensation, I don't use. Automatic battery profile selection, I don't use. Continuously trim servos on fixed wing, I do like that feature and I enable it. Basically, when you're flying in an auto level mode, it will learn basically how to trim the model to fly straight and level. And then when you switch back to manual mode, your servos will already be trimmed and it will continue to fly straight and level and already trimmed out for you. So that's a great feature. I really like that about iNav, and I always enable that. So now we'll go back and look at this side. We want battery and voltage monitoring on. We have an ADC, we want the raw source for telemetry, voltage scale, and your ADC for your current monitoring and everything, your offsets. We're not going to mess with this. You can calibrate these, and Darren has some good videos and tools for calculating these numbers and everything. If you want to fine tune it with an actual meter, a power meter that can read your battery voltage current, you can fine tune these and get them perfect. But personally, I've always had good luck with the Maytech boards. They seem to come pretty well spot on. I've been able to fine tune a couple of them, but it usually wasn't worth the effort. So I would recommend just trying on the defaults. And my GoPro is overheating and turning off, so we're not going to have the image of the model for now. we'll turn it back on if we need it. But yeah, run these on defaults and check it, and if it doesn't match what you're actually draining out of your battery, or your current doesn't look right or something like that, you can double check them. But go to Mr. D Falling with Style, which is Darren. Go to his channel, and he's got some great tutorials on setting this stuff up, so I won't try to reinvent the wheel there. Battery settings, you can leave this on auto. I always run a 3S battery in here, so I'm just going to set that. Now I'm going to lower this 3.3 down to 3 volts for the minimum cell voltage, because I'm running the lithium ion pack, which you can actually run these in like 2.5 or so. But I'm not sure if this is only for detection or not. I'm not sure what this is used for. But I do set my warning cell voltage. I like it to warn at about 3.2 volts per cell, so I'll go ahead and set that. And like I said, I have a 3000 milliamp hour battery in here, so I'm going to set it to about 2850, I guess, just to give us a little bit of a margin for error. And for my warning capacity, I like to set the warning, which is your remaining percent. I like to set it to about 35, or let's do 35%. And then critical, we'll set that at 20%, just to, I mean, you might want to set this at 50% if all you're doing is flying long range, flying out and coming back. When you get to 50%, you definitely want to turn around and come home. Now that is allowing a little bit of safety margin here. Like I said, I have a 3000 in here, but I set it for 2850, so I have a little bit of margin. But if you're only going to be pushing out for maximum distance and turn around and coming back, you probably want to set this at maybe 60-65%, just to give you a little bit of warning that, hey, I need to keep an eye on my battery. And I'm almost to the point of no return right now where I need to turn around so I can make it home. Just set these accordingly depending on your needs and what you're doing with your airplane. Now right here, because I have smart audio enabled, I can set that here. Personally, I'm using Bosscam E on channel 5, which is 5885. And for now, we'll leave it on the low power. And I'm not going to enable this yet, this use low power until craft is disarmed, or while it's disarmed. What I usually do is I'll come back after I have everything set up. I'll come back and set this to until first arm, which basically keeps it on the lowest power setting, which in my case is 25 milliwatts, until the first time you arm the airplane. And the reason I do it until first arm is in case I ever do lose an airplane and I have to go and find it. If you get close enough to pick up your video signal, it can maybe be transmitting your GPS coordinates. It would help you find your airplane. But if you crash the airplane and you disarm it, and then you need to rearm it to get your transmitter to transmit higher power again, you may not be able to disarm it. You may have a sensor pull loose or something like that. Depending on how you damage the airplane, there's a chance you may not be able to arm it again. So I like to use this as until first arm, so that even if I disarm the airplane later, it's going to stay in high power unless I disable it with the radio, which we'll set up later. But for now, I'm going to disable this and just leave it on low power while we're setting things up. So we'll go ahead and save and reboot again to save all these settings from this page. So now we'll set up our failsafe page. By default, it comes to land. I like to set to return to home, obviously. And that's pretty much all we need to set here. We'll go ahead and save and return, save and reboot. Alright, and again, your PID tuning. I'm just going to show you this page because it has made some changes in 5. They have these nice sliders and everything now, and all your advanced settings are further down here in tables, that you can still access them if you need to, but there should not be any need to, unless you really know what you're doing. Personally, I've never used these. These sliders here, I guess if you wanted to manually set up your airplane, you can do it. Personally, I don't ever manually tune my airplanes. I just use an auto tune and I'm happy with that. Rates and expo is still similar to what they were. Again, I'll leave these on defaults, and auto tune now will adjust the rates, so I'll just let it do that. but I never adjust these unless I need to tone. If anything, if I'm flying a fast twitchy airplane or sometime, I might lower these a little bit, but I'll just let it tune itself and then we'll go from there. Filters, again, that's something I don't really mess with. I don't even really know how, so you'll have to look elsewhere if you want to know what these do and when you should use them. Mechanics, again, that's beyond what I like to do. The only thing I'll touch here is the fixed wing level trim. Normally I wouldn't adjust this. You can actually set that in flight mode to your fixed wing auto level, and it will trim that for you, and we will set that up anyway. But for now, I can refer back to this document here, which is my dump from 3.0.1, and I can get this value from there, my fixed wing level trim. So what I'll just do, I'll come here and I'll find, you see I've already done a search for trim, and that's feature, so we can find next. We're looking for, okay, not the limit, we're looking for this value right here, fixed wing level pitch trim. Mine was 4.901 previously, so I'll just set that here to 4.9, and we'll save that. Like I said, if you have a dump, configurator back up this here. If you have a dump with this value in it, you can reuse it. It'll just kind of start out closer to where it'll end up later. Kind of a little shortcut to get it flying a little bit better right off the bat. But if you don't, just leave it on 0 and it'll tune itself later. So advanced tuning, I don't remember if there's anything in here. Yeah, we'll do our Rth settings in here. Alright, so idle throttle is basically all the way down to idle, which I believe this is yellowed out because we have set to stop the motors on idle. No, never mind, this is your auto launch settings. Sorry. Once again, I'm not using auto launch. So I will revisit this stuff later once I do start using auto launch. But for now, we're not going to touch anything here or here. Navigation settings, for now we'll leave cruise throttle at 1400, which is a little bit lower than half throttle. Pitch to throttle ratio, you can adjust that if you need to allow manual throttle increase. That basically gives you, kind of explains right here, you can raise the throttle with the throttle stick if you need to while it's in cruise. I'll just leave that off for now and let it do its auto throttle. You set your min and max right here for throttle, for the auto throttle range. Throttle smoothing, all that stuff that you probably don't need to mess with any of this right now. After you fly it in your navigation modes, if you want to come back and fine tune this stuff, you can, but for now it's probably best just to leave them alone. And once again, I like to use, for my Rth altitude mode, I like to use at least with linear descent. And Rth altitude, this is in centimeters. I'm actually going to pull up my browser over here on the other monitor. I'm just curious, what is 5,000 centimeters in feet? Because I do use imperial units. That is 164.042 feet. So basically 164 feet. I like to set my altitude a little bit higher. I'm going to go for 300 feet. So 300 feet in centimeters is 9,144. And my Rth home altitude, which is basically once it reaches its home position, then it will lower the altitude from this altitude to a lower one. And basically once it starts loitering around home, it'll lose altitude back down to this second number that you set right here. If you leave it on 0, it just disables that feature. But I do like to use that feature, and I'll lower that to 150 feet once I reach home, which is 4,472 feet. 4,500, I'm sorry, and 72 feet. And basically, just once it starts loitering home, it'll drop down to 150 feet. Just gets lower, easier for you to find the airplane and get a good visual fix on it if you didn't already have one. If you were flying, FPV and have to rely on Rth to get the plane home if you lost a video transmitter or something like that, or your camera goes out or whatever, it just makes it easier to spot the airplane and land it line of sight. Climb before RTH. Again, I like to use on fixed wing spiral mode. Leave these turned off, which are the defaults. And land after RTH. Again, we like to put that on never. And I'll leave these leave these alone right now on the defaults. Now your navigation settings, I don't think there's anything to adjust over here in waypoint. And automatic landing settings, we're not doing automatic landing, so we're done here. We can save and reboot. And a lot of this stuff is just personal preference, like probably more than half of it is personal preference, but these are my preferences and I'm just kind of showing you how I set airplane up. Alright, programming. We will revisit this later. I'm not going to do it right now because it's a little bit long and drawn out. And we actually need to have the receiver set up and working before we do this anyway. In the programming tab. This is where we're going to, the only thing I'll use this for is to set up, to control my video transmitter power using a switch on my radio. But we'll come back and we'll do that last. So receiver. I have a serial receiver. My AETR is the right mapping. It matches my radio, which is basically ailerons on channel 1, elevator on channel 2, throttle on 3, and rudder on 4. I do need to change the protocol to CRSF on a crossfire receiver. Everything else can stay good here. We'll go ahead and save and reboot this. And now I can actually turn my radio on now.
Welcome to Edge TX.
And we should link up, and there we go. We have control over roll, pitch, throttle, and yaw. As well as my arming switch is on channel 5. My mode switch is channel 6. We'll go ahead and leave this working for now. So we can go in here and set up my modes. I need to grab my cheat sheet, which I always keep this on my desk. It just shows 1 through 6 because I have my mode set up on the 6th position switch on the Radio Master transmitter, and I have 1 through 6 are manual, angle, cruise, waypoint, return to launch, and failsafe, respectively. And once again, my mode switch is on channel 6, but first thing we want to set up is arm, and we want to add a range, and that's on channel 5. You can see if I move my arm switch there, we want to set up a range up here to be armed, and that's disarmed. So that's working. We'll save that one. I want to uncheck hide unused mode so that I can see all of my flight modes here. So now we want to set up all of my flight modes on channel 6. So manual for position 1. We want to add a range here, and we want this to be channel 6.
Angle mode, manual.
Alright, so that's moving as expected. So we'll set up a mode down here, a range for manual flight mode. Now you can see
angle mode, manual.
When we select manual, it goes to manual. So now we'll do the same thing for angle. We'll add a mode, a range for 6. We'll put this angle mode, and you see the indicator there. We'll set that like so. Save that. Next one is going to be cruise, which should be why don't I see any of my navigational modes? Maybe we haven't enabled GPS yet, so let's go to GPS. GPS was not enabled. We set it on the port, but later I think we forgot to save it in that configuration tab. But we want to enable GPS, set view blocks protocol, ground assistant type. We're in North America, so we'll set that. We don't need Galileo satellites. We're not going to set time zone or daylight savings time right now because we're not using the time for anything just yet. You can set that if you want, so the airplane can get its actual time and date from the GPS more accurately. You know, if it knows where it's at, time zone. but we've enabled that, so we need to save and reboot so that the navigation flight modes will show up. You see that's a couple of times now. Well, I actually forgot to save it on the configuration tab once, and it's been a problem twice with the servo outputs and also the GPS. So we need to go back to modes. Now that we have a GPS enabled, it's not communicating. You see it's red up here because it's not powered while I'm just powering the flight controller from USB. But it will enable our navigation modes now. So back to what we were doing, we need to set up channel 6 for cruise mode, which is navigation, nav cruise. We want to add one here. We'll set a range there for cruise mode. Wider than that. Save that. Now I like to do cruise and altitude hold at the same time, because I believe you need to enable both. It's not going to... I don't remember if cruise mode actually holds altitude or not. I know I used to do this in the older versions of iNav, but it may or may not still be necessary. Once again, Pavel, Darren, Mark, one of you guys, I'd appreciate it if you hear this and you want to chime in. Or if I find the answer, I'll put a note in the description as well. So our next flight mode, number 4, is our waypoint flight mode. So that would be nav waypoint. So we'll drop that. Channel 6, let's see what channel 6 is, and it will respond to the right channel anyway. Just set that range right there for waypoint. Next one is going to be return to launch, which we have RTH. Again, that's channel 6. We're going to set a mode right there for RTH. Save that. And my last one is to manually trigger a failsafe. And I only have that because I have room on the 6 position switch. It's not something I use very often. I just use it to make sure the airplane is going to behave as expected in a failsafe condition. It just lets me manually trigger failsafe, so I can put that right up here at the top of channel 6, like so. So now I have all my modes set up and working.
Return to launch, failsafe on.
So everything there works as expected. So that's our modes tab done. The only thing I want to set up is auto tune, which, if I can find that, that should have been in the fixed wing setting right here. I have that set up on a switch on channel 7, so we'll add a range for channel 7. You see that moves there, so we need it down at the bottom end of channel 7. We want to save that. So that lets me enable auto tune with a switch. And I think that's the only thing I needed in modes, if I remember right. So adjustments, this tab, we never set anything here. I've never used these personally. We already set up the GPS. Magnetometer, we don't have one of those. Mission control, we'll do all that stuff later. OSD is about the last thing we're going to set up here. Now this is where it gets a little bit complicated. Well, it's not really complicated, it's just a little bit drawn out, and it will make this video longer than it's already turning out to be. There's a lot of and there's a lot of things you can do here, and it's basically all going to be personal preference. Now it comes set up like this by default. What I'm going to do, take a shortcut, is I'll scroll back to right here where you see this OSD layout. So I'm going to start copying from there. See this layout 0. You want to copy all the way down to the end of OSD layout 3. We want to copy all of that. We want to go to the CLI. We want to right click in here. We want to paste all of that. We want to hit enter. And we wait for this to populate. This is basically copying my OSD layout that I had in iNav 3. And we're restoring that OSD layout back to iNav 5. I think I called it OSD 3. It's in iNav 3. Now we're taking the OSD from iNav 3 and we're restoring that into iNav 5. So once this finishes running, we can go ahead and hit save, which will save this into the EEPROM, and it will reboot the flight controller. And it's going to reconnect, and we're going to go back to the OSD tab, and we're going to have to wait for it to load data once again. Just be patient, it has to pull in a lot of data, apparently. And there we go. Alright, so now you can see it's starting to look a lot more like my OSD did previously. Now you notice my OSD is kind of shifted up on the screen. That's because I'm running an NTSC camera. So if I actually set this to NTSC, you can see the difference between PAL and NTSC. So I like to not use auto. I like to set this on NTSC. And we'll just go ahead and save that. So now there's obviously some things are not going to be perfect. They're going to be different, kind of laid out a little bit different. So just kind of go down these settings and go over things. Some of this doesn't translate over from that layout. You know, these settings don't necessarily translate, just the layout. So we want RSSI signal strength, battery voltage. Just kind of looking through these things here. We use auto throttle position, craft name. I don't even have a craft name set anyway, so I'm not going to enable that. Flight mode, system messages, heading. I just use the heading graph, which is a compass. I don't necessarily use the heading. One thing I do like, I don't remember this being in older versions of iNav, or maybe I just overlooked it. As I move the cursor around and highlight things on the OSD, you notice over here on this side, it kind of highlights which setting it is to kind of show you if you're curious about which one it is. Time of day I don't use, RC source I don't use any of these. This temperature stuff I don't use that. We use altitude and numeric vario. Do I use that? Where is it? Numeric vario. Oh yeah, right here. Shows your height climbing or descending in feet per second in my case, because I do use imperial units, which we do need to go back and change, but that's up here. We'll get to it later. So yeah, I do use that one. I just didn't remember what it was. I was thinking vario, like a glider, but it's just basically your climb rate and descent rate. Alright, so moving on, G-force, I don't use those. Timers, I do like this on and fly time. It'll show you how long the flight controller's been on until you arm it, then it starts counting your flight time. I like that feature. It's kind of both timers in one, kind of automatic for you. Crosshair, which is the thing here in the center of your AHI, I do leave that on. Artificial horizon, obviously I leave that. Horizontal sidebars, which is these here, I prefer personally to turn those off, and it just kind of gives you a cleaner OSD. Pitch and roll angle, I used to use those when I had to manually tune the board offsets to get the airplane flying level, but I don't find them that useful anymore since it does it all automatic. Which reminds me, I do need to go back and set that board level mode, I think, if I remember right. I don't think it's gonna be anywhere else, but we'll go back and double check that. Current draw milliamp hours, do use that. I don't use any of these. For this particular airplane, those GPS, ground speed, satellites, direction to home, distance to home, HDOP are the ones we use. Radar. This video transmitter power level is this low number up here that I do use. And I noticed they added this little VTX symbol next to the number. I'm actually going to move that over a little bit. It used to be just a number, but now it has a little VTX icon next to the number, so you kind of know what that represents. Transmit power in milliwatts, I do use that. That's right up here. It shows me how many milliwatts my Crossfire transmitter is currently transmitting, and it gets that through the telemetry. I like having that, so I'll enable that. This is something new, switch indicators. We're going to look at that in just a minute, because we need to change some other settings. I mean, we could turn one on now, but we'll change that and come back to it. Global variables, I don't use those. Don't need anything down there, so let's go back to this set of views, imperial units, and you see these do switch to miles per hour and feet, miles from home, and feet per second, feet altitude, and all that good stuff. Voltage decimals, this one here, I find 1 decimal is fine. Milliamp hour precision, 4 digits is fine. That's another change you can do for 5 or 6 digits. I think that was one of the new features. I'll give you a link below this one to Darren's video. He explains all the changes in 5.0 in detail. But I believe that was one. Coordinate digits, I'll just leave that set here. Plus code digits are fine. Plus code move leading digits, I don't deal with that. ESC RPMs, I'm not using. Crosshair style, you can change the style right here. Have it look like that, or a little small one, or we can set bigger square one, or we can set kind of diamond shaped one, or we can set that one slightly different, or we can set this kind of little X looking one, or this kind of little weird flat one. Out of these, I prefer the small one just because it's less intrusive. Now, these do change with the font, which we do need to run the font manager after we finish this anyway, or you could do it before, but we definitely need to have this looking right. In a minute, I'll power up the transmitter and show you what the analog feed looks like if you don't fix the font. If you use the vertical scroll bars, you can set what they'll kind of scroll up and down if you want them to, according to what these are. You have a couple of things you can pick from, but again, I usually turn those off just to free up some of the clutter in the OSD. Crossfire link quality format, I usually leave that alone. Scroll arrows, and again, that's if you're using the sidebars, which I'm not. Home position on the arming screen, I turn that off because I always fly in the same location and I always arm at home. And it just doesn't show my GPS coordinates in the video too. For posting online and stuff like that, I prefer to have it off. Alarms, minimum RSSI, I'll leave that there. Flight time in minutes, I always fly more than 10 minutes. I guess we'll set that to 15 minutes for this airplane, which we'll do it 20 minutes. The airplane can fly a long time on the battery that's in it. Height for altitude, I like to set that at 400 feet. And I need to look at that in meters, so that's going to be 122 meters. So if I get to 400 feet, it'll start flashing to let me know. Negative altitude, 5 meters is usually good. I do see it drift a bit further than that. Sometimes when I land, it'll show them lower than that, but it's all flat ground, and where I'm at, I can't physically fly below where I arm anyway. So I just don't bother with it. I guess it's useful for someone launching from a mountaintop. They don't want to fly too much lower than their starting point for some reason or whatever. But for me, it's not an issue. Distance for home, I usually set that at about 1 mile, which I know is 1.6 kilometers, so we'll do 1,600 meters. And again, these three are in meters. So when I get to 1 mile, it'll start flashing down here to let me know, which again, the airplane can fly further than that. It's just, I usually do set mine up to alert me when I reach the first mile for some reason. It's just something I've always done. G-force, I don't bother with those. Current, I don't set that. If you just leave it 0, it disables it. I mean, if you're worried about pulling too many amps for some reason, you can have that flash if you get above a certain level. You set that here. Temperature, I don't bother with. Crossfire link quality, RSSI, signal to noise ratio. If you use those, you can have them alarm as well. And their default values are pretty decent for that, I believe. Don't use the DJI HDPV stuff for the OSD there or whatever. Okay, now this is what I want to get back to. Switch indicators. let's go ahead and turn one on, because we are going to use one. So we're going to switch on one, which you can see it popped up right here on the OSD, this little flap. You can decide which side you want to switch on the name. I like it, I'm going to leave it over on this side. The actual little switch is going to be to the left of the name. I'm going to name it Inactivity Alarm for my radio. But we're going to name the switch indicator VTX, because we're going to use it to let us know when we set the VTX power, which in my case is channel 8. So I'm going to let it look at channel 8. Alright, so I want to move it right down here on the OSD. Do we want it? We're going to put one space between satellite count and VTX. So basically on my OSD, that'll show me the switch position that I used to set my VTX power. I also have the power level up here, but I do like having that little switch down here, just mainly because I think it's a really cool feature. You can have up to 3 of them. Like I said, we turned on the first one. There's 3 more that we're not using. You can name them anything you want, up to 4 characters, I believe. Can you do... Oh, I guess you could. Let's set this one to... So it's up to 5 characters that you can have. But we're going to name it VTX, and it's going to watch channel 8. You can set each one to any name you want and let them look at any channel you want. And basically it'll show you your low, middle, and high position for that specific channel. Which works out great in my position because I'm using a 3-position switch to set my video transmitter power. So everything here is set, so we're going to save that. Now, give me just a minute. I'm going to turn on my analog feed, which is not showing right now. We're going to power up the airplane. I think I need to power cycle my capture card, get it to display, so bear with me for just a minute. Usually takes a minute for it to boot up. There it goes. And like I said, you see that kind of messed up font, like down in this corner is my analog feed. So I'll actually make that a little bit bigger for now. So you see that font is all messed up. It's because we're using a newer version of iNav, and they have actually made a lot of changes to the OSD, so the character layout is all different now. For the better, from what I understand. But anytime you change your iNav version, you want to come into the font manager. You want to pick the font you want. In my case, I'm just going to go with the Vision font is one I like. The Vision font. Take a minute. Come on. Or did it actually leave? Okay, so we loaded Impact Mini and it did load that one, so we want to load Vision font. And there it goes. It takes a minute to update because as you can see, it does give you a preview up here of what the fonts are going to look like. But I like to use the Vision font. Sometimes I'll use the different ones, but for now we're going to stick with the Vision and we're going to upload that font. And you see you get a progress indicator over here. Or actually my analog feed is covering some of what I'm doing. But there's a Vision, the progress indicator that you can see over here. And when it finishes that, it's going to reboot. And you can see everything's coming up on the screen right now on the analog feed. And now our OSD looks fine. Now that little VTX switch down on the bottom of the OSD, when I move the switch on my radio, you can see what that does now. So the bottom switch is our position, it's in the middle position, and now it's in the top position. So it's just a little visual reference for any extras that you might have on your airplane, be it flaps, landing gear, in my case, video transmitter power, whatever you want. They're very useful, and I know that's a feature that Darren added, because I remember reading that in the release notes, and I'm personally a big fan of that, and I thank him for that. So we're going to go ahead and connect back to the flight controller, and we're going to go back to the OSD tab, because I do see one thing I need to adjust. My altitude in feet, you can see it's getting cut off of the right side of the image there. I'm going to move that over 1 character space. As soon as we get it to connect here. And I'm also going to kind of size this back down a little bit so it doesn't block so much of the screen. Alright, so I want to grab my altitude right here and I want to move it over 1 space. And save that. Did it actually? There it is. So now you can see that has actually updated over here on the analog feed. So we want to save that. Okay, so we have everything. We have the AHI is working. Everything's good there. Manual. Go back to manual flight modes, and the servos are not going crazy when we move things around. So that's all working as expected. Everything looks good there. A couple of things we need to do. We need to go back, now that we have everything powered up, we need to go back and double check our flight surfaces, make sure they work. So let me power my GoPro back up. Try to get it going again. Alright, so we should have everything synced up now. GoPro is recording. So now, like I said, when we move this, you can see on the screen the AHI actually moves like it should. So let's go back to our Outputs tab. And I'm going to go ahead and turn this around just to make it a little bit easier to visualize what's happening here. And I'm going to try to get my radio in the screen as well, at least the right stick. So now when I pull back on the stick, you notice this elevon's working right, it's lifting the way it should. This one is not, this one's going down. Same if I roll this way, this one kicks this wing up, this one should go up to lower this wing if I roll this direction, but it's not. So we need to reverse this servo. And you can look over here on the screen. That is, actually we need to go back to the mixer. Okay, so that elevon is servo 3 that's wrong, so now we need to go back to the Outputs tab. And we need to find servo 3 output S3, not servo, it's actually servo 1, but it's on output S3. And we need to find that, and we need to reverse that one. We need to save that. Now if we pull back on the stick, both elevons raise. Push forward on the stick, they both go down. We roll this way, they work right. We roll this way, they work right. So those are going to work right now. And we can go to angle mode. And we want to pitch nose down. And trying to keep this in the camera, but you can see both elevons are lifted. And if I pitch up, you can see both ailerons are, well, going down. And the same thing if we roll it, you can see it lifts this aileron and lowers that aileron. There's that one. So everything is working right for both manual control and stabilization. So we'll go back to manual mode. So we will set this right over here. Actually, move my little stand for it. So that's working right. So we got the controls. Everything is working as expected. So we can save and reboot to make sure those get saved. Alright, everything's back up and running. So the last thing we're going to do is set up that video transmitter power control. Because right now, if you watch over here on the OSD, get the mouse pointer where you can see right below where I'm pointing right now, you see that VTX1. When I move my VTX switch, which you can see on the bottom of the OSD down there, when I move it, that power should go up to, it should be power level 2 when I'm at the bottom, 3 when I'm in the middle, and 4 when I'm at the top, which is 200, 600, and 1200 milliwatts for this video transmitter. So to set that up, we'll go back to the programming tab. And we basically want to enable 6 programming lines. This is going to be trying to remember how to do this, because this did change in iNav 5. We want this to be RC switch check, so we want this, we want it high. Actually want this one to be medium. It doesn't really matter, I'm just kind of keeping them in order, just for simplicity's sake. And I did it again. They're listed in the wrong order here, which is kind of annoying. It's high, low, medium. But I basically want these set high, medium, and low. And I want to get RC channel, and I want that to be, what channel was that? That's channel 8. So I want to set that to channel 8. Get RC channel, channel 8. Get RC channel, channel, save these. And these are always active. Now you notice these 3 status icons right over here. As I move the VTX switch, which you can see it moving on the OSD, as I move it, these logic conditions become active. This is logic condition 0, 1, and 2. When the switch is in high position, 0 is active. When it's in mid position, 1 is active. And when it's in low position, then 2 is active. So we have that working. So now we want to set an override. It's actually not an override, it's set VTX power level. So we want to change all 3 of these to set VTX power level. And we want to set it to a value. So for high value, we want it level 4. Mid, we want it on level 3. And low, we want it on level 2. And we want it always active, and we want to click save. And something's not working right because actually we don't want this. We want it to be a logic condition. I think. I'm trying to remember how to do this. So we want this on logic condition 0, want this on logic condition 1, want this on logic condition 2. Actually, no, I did have it right. We want to set our value here to level 4, 3, and 2. I did have that right. You need to change your active. We want this active only on logic condition 0, only on logic condition 1, logic condition 2. That's what I messed up. I'm going to do this by memory. Now you see they're not active. Now when we change them, you can see they flash over here. They just kind of momentarily activate as we activate these. And you can notice right over here on the OSD, right below where I'm pointing with the cursor, it actually switches the video transmitter power level according to the VTX switch, which you can also see. You see that changing up here, and you can also see that on the bottom of the OSD. So that's working now. So we can set high power, middle power, and low power on the switch, and then we still have that 25 milliwatt power mode. We want to go ahead and just click save again and double check, make sure we save that. So now we'll come back to the configuration tab, and now that we know that's working, we can manually change the power levels according to what we want them to be. We will just go ahead and default this to power level 1, and we'll actually not save and reboot because it takes too long to do it, but it would basically show you that I can still override it with 2, 3, and 4 power levels with the switch. But we'll leave this low power until the first arm, and when we save and reboot, it's just going to basically lock the video transmitter into the 25 milliwatt power mode until it arms, and then it will move up to whatever my VTX power switch is set at. So once again, you can see on the OSD over here, it's at power level 1 now, and changing the switch doesn't adjust the power level anymore, but after the board is armed, then the switch starts working. So it lets me leave the airplane outside, sitting in the sun, getting a GPS lock or whatever, running in the lowest power mode possible until I arm the airplane, then it'll jump up to whatever my switch is set at and I can control it from there. So that's pretty much everything. The only thing I will need it to go back and do, I forgot to do earlier, I want it to set in modes. I want to set auto level. And again, this is what auto trims that level. And I want mine active while I'm flying in angle mode, which is channel 6, that range. So we're going to put that in angle mode. We're going to add a range on channel 6 to the same range as angle mode. So anytime I'm flying in angle mode, it's also going to have auto level active, which will automatically adjust that parameter earlier for your auto fixed wing board pitch level setting, whatever. And like I said, I did pull that value over from a previous install of iNav, which was 4.9 degrees. So we should be pretty close from the start. But now anytime I'm flying in angle mode with my hands off the controls, just letting the airplane fly itself in angle mode, it's going to trim those servos for me. So that's something I don't have to worry about. So we'll go ahead and double check that we've saved that. Make sure. And I like this feature too. You can hide your unused modes. Now we have just a list of everything we're using and nothing that we're not. So everything's good there. So the last thing I always want to do is I'll come here and once again we'll get a dump. And we'll let that populate and we'll copy the clipboard and we'll go paste that into a new text document to save. And I'll name that something like iNav 5 before maiden or whatever. And you can see that's done now. You just hit copy the clipboard and that's done. You can go paste that in a file and save it somewhere just so that you have a backup of all the progress that we've just made. And there's my GoPro overheating once again. Because I am doing this with my air conditioner off and it is pretty hot in here, but I'm doing that so that it doesn't make noise in my microphone. So that's what's going on there. But we were done with it anyway. We can go ahead and power off airplane. And we will hide that. And we'll unplug that. And disconnect. Power off the radio. So we're done here. Next video is going to be a maiden flight. And auto tune. We'll run the auto tune, we'll land and save that, and it'll be smooth sailing from there, hopefully. So stay tuned for that. I know this video has been long. We're going on like an hour now. I may even cut this up into more than one video, but you'll know by now if you made it this far into it. But that's how I installed iNav 5 on my Dart 250 and carried over some of my previous settings and things that were already configured before. So yeah. Thank you for watching this video, and thank you to Darren and Powell and Mark and anyone else who's ever worked on iNav. Those guys in specific, in particular, they've specifically taken time to help me with questions over the years, not just recently. And for all the time that they spend making this all available to us. And of course to each and every one of you that watches the video, and all my channel members and Patreon pledges and people who... One guy used the thanks thing on my last video and made a $10 donation, so I'm very, very grateful for that. It's the first time anyone's ever done it. But yeah, stay tuned and we'll get it in the air as soon as possible and go from there. So we'll see you all then.